Hello students. So we'll do some problems based on application of derivatives. Okay. And these questions are word problems. Okay. So they are based on the minima, maxima, okay, and increasing or decreasing. When one quantity is increasing, okay, you have to find what is changing. Other quantities are changing or not. So let's start with this question. Okay, first of all, you should know all the formulas, okay, related to 3D geometry, that is solid shapes. Okay, cone, cylinder, cube, cuboid, areas you should know, then volume, okay, then lateral surface area or chord surface area. Then also you should know 2D figures like area of a circle, area of rectangle, square. Okay, mostly these things are used in this word problems. Okay, so question is the distance traveled by the particle in time t is given by s equal to 2 plus 3t minus t square plus t cube. Find the velocity when the acceleration is 0. Okay, now here you should have the knowledge of how velocity is defined in terms of distance. Okay, so velocity is given by change in distance upon change in time, right? That is how we write speed. Speed is equal to distance upon time. Okay, then how acceleration is written? Change in velocity with respect to time. So this becomes your double derivative of dx by dt square. Okay, so this is our distance. So in place of x we have s here. Okay, so if you derivate it with respect to t, that is change in distance with respect to t, that is our velocity. 3t square. Okay, so this is our velocity. Now acceleration is given by its double derivative. So this is minus 2 plus 60. Okay, and here it is given that the acceleration is 0. Okay, so if it is 0, then we can find the value of t. So t is 1 by 3. Okay, so they have asked to find distance traveled by the particle in time t is given by this. Find the velocity when the acceleration is 0. When the acceleration is 0, our t is 1 by 3. So that we have to put in the velocity. Okay, so we have to differentiate this dv by dt 3a square and then differentiation of a with respect to t. Okay, now a is given, so we can write here dv by dt when a is 10 centimeter. Okay, we can substitute it 10 square, that is 100, and dA by dt is also given 3. So this is 900 centimeter. This is volume, so centimeter cube per second. Okay. Next question. An open pipe with length 3 meter and outer radius 10 centimeter has an outer layer of ice. Okay, that is melting at the rate of 2 pi centimeter cube per minute. How fast is the thickness of ice decreasing when the ice is 2 centimeter thick? Okay, so here pipe is given. Pipe means it is the shape of cylinder, right? So if you have a cylinder, say this is a pipe, and it is given that length is 3 meter, means its height is given which is 3 meter. Okay. And outer radius 10 centimeter has an outer layer of ice. Now what is happening here? This is our pipe and we have a thickness of ice. Okay. Here we have a ice. Okay. So this becomes our one more cylinder outside of ice like this. Okay. Okay, like this. So that is melting at the rate of 2 pi centimeter cube per minute. This volume, that is of ice, is melting at the rate of 2 pi centimeter cube per minute. So how fast is the thickness of ice decreasing when the ice is 2 centimeter thick? Okay, now we'll write what is given. Now here pipe is given with the length 3 meter. Now see here everything is given in the centimeter. So we have to convert this into centimeter. So our height of the pipe is 3 meter, which is you have to convert it to centimeter. Okay. Now the has a radius. Radius is given 10 centimeter. This is the radius of the pipe. Okay. And we want this radius also, that is with the thickness. Okay. Thickness is given, thickness we have to find, right? How fast the thickness is decreasing. So let thickness be x. Okay. This part, this thickness I'm taking as x. So we have, this is the pipe and this is our thickness, that is x. So total radius with thickness is r plus x, right? R is our 10, so 10 plus x. Okay. Now this ice is melting at the rate of 2 pi centimeter cube per minute. So outer volume, that is volume of ice, that is outer cylinder, okay, is decreasing. It is melting means decreasing, so negative sign. 2 pi centimeter cube per minute. Okay. How fast is the thickness of ice decreasing when the ice is 2 centimeter thick? So here they have given x value. We have to put this and how fast the thickness is decreasing. So we have to find dx by dt. Okay. So this is change in volume. So we can write here dv by dt. Okay. You have to find this. So what will be the volume of this outer part, outer layer? Volume of outer layer will be what? Volume of full, that is with this outer layer. Volume of full pipe with ice minus volume of pipe, right? We have to remove this pipe so that we'll get this volume, outer volume. So volume of the full pipe is pi r square h, right? So r here is, that is total radius with thickness 10 plus x. Total radius we have to take full. So r plus x square into h is 300. minus volume of the pipe. Volume of the pipe is pi. Radius of the pipe is 10. 10 square into h. Okay. So we'll take common pi into 300. So inside it is r plus x the whole square minus 10 square. Okay. This is the volume we want. No, this is the volume which is given. That is volume of the ice. Okay. This is same as, this is changing volume. Changing. Okay. So volume of ice. So change in volume of ice is given by dV by dt. Right. So differentiating this, we'll get 2 into r plus x into dx by dt, and this is 0. Okay, now let's put dv by dt, which is minus 2 pi into 300 into r is 10, right? And x they have given 2. We have to find dx by dt, that is change in thickness. Okay, pi gets cancelled. This will be 12. So 12 to the 24, right? So I'll write it here. Dx by dt minus 2 upon 300 into 24. So minus 1 upon 3600. Okay, so this is change in thickness, centimeter per minute. It is decreasing, right? So that's why it is negative. Okay.